In this video, I'm going to talk about a machine learning algorithm called K-nearest neighbors. I'm going to discuss the essential concepts so that you understand what this algorithm is and how it works. And the stuff that I'll be talking about is part of a blog, the link to which is provided below this video, so feel free to check it out. Let's get started. So what is K-nearest neighbors algorithm? In K nearest neighbor, I have denoted it as KNN, we have a labeled data set and we want to use it to predict an unlabeled query point. Let's consider this example. I think going with the sample data set will make things easier. So I've taken a data set which has a list of movies, just three for our purpose. Uh, if you see these three movies, you may be familiar with them, or you can choose any movies of your like. The data set contains certain attributes. You know, these labels that you see, this row, these are all features like name of the movie, who is the lead actor, the genre, the director, the production, and whether the movie was a hit or a flop. So, this is the label part basically. So, for each row, we have classified it as hit or a flop. Idea is that when a new movie comes in, say another Amir Khan movie comes in, and we want to predict whether the movie will be a hit or a flop, then we want to make use of this data. Obviously this is a very minimal data, and in real life you will have maybe millions of such records, and our algorithm is going to make use of that. But for this example, we are going to stick to this. So this is a data set I'm going to use. I think most of you are familiar with movies and all, so it makes things easy. So as you can see in this data set, we have box office as the label. Okay, and based on the attribute values, a movie is classified as a hit or flop. The attribute values means like name, lead actor, and stuff like that. So KNN helps us predict if a new movie will be a hit or a flop using this data. Like I mentioned, a new movie comes in and I want to check whether it's a hit or flop. I'll make use of this data. Okay. So a given movie in this data set can be represented as a vector. Now, for those of you who have some maths or physics background, you will know what vector is. If not, I'll suggest that you refresh your concepts of vector. You just need to know the basics, what a vector is. I think most of you will remember that a vector is a point in space with a magnitude and a direction, right? So a vector has a magnitude and a direction. You can refer to a Wikipedia article that I've shared here. It's Euclidean vector. And if you see, this is a vector, for instance. AB is a vector, it has a direction and it has a magnitude. Okay. So that's basic of a vector, because why we need vector? So that it makes things easier for us, to utilize the mathematical concepts, like you will see later in this article. And I've mentioned converting to vector enables us to use the mathematical approach to solve such problems. And for instance, this movie Dangal, we can represent all these attributes in a vector format. Okay. So it can be like some numeric values, 1, 2, 3. Obviously, you need a transformation to do this, but consider that you have a transformation algorithm available. So you can use that to come up with a vector for this movie. Okay, and this really helps us to compare 2 points very easily. Okay, so if I have two movies with such vector, you can understand that comparing will be very easy. You can know how much difference each value has. So another can have 1, 2, 4, 5, and then you can know that okay, 1 is similar, 2 is similar, what is differing. So that ways it helps us to compare 2 points easily. Okay, let's come to how KNN works. So far we have looked at some basic concepts like the data set and a little bit about the vector and stuff. Let's see how KNN works in practice. So at a high level, it's a two-step process. We look at the given data set and find k data points that are similar to the query point. We'll discuss similarity shortly, and from this list of similar data points we do a majority vote. See, the idea is when a new movie comes in, we want to see what similar movies do we have? Okay, so for instance, an Amir Khan movie is coming up, so we know, okay, Dangal may be one movie we can compare, and we can have another similar kind of movie. So those will fall under the same bracket, having the same actor or same director. So we want to pick up a list of points which are similar to each other, similar to the new data point that we are going to analyze. So we analyze the data set, we find k data points. K in KNN, k can mean k can take a numerical value. It can be like 1, it can be 2, 3, 4, 5. Generally, we take k value as an odd number, and then what we do is we try to do a majority vote. So if we have 5 similar movies, then we try to see what is the majority what is the majority saying, like does were the majority of the Amir Khan movies a hit or were they a flop? So if they were a hit, chances are pretty high that the new movie will also be a hit. If not, it'll be a flop. I think that's very common sense approach, right? It's very simple. There's nothing fancy about it. You try to find similar points and then you try to do a majority vote. Okay. Let's go to the KNN algorithm. So for KNN, we divide the data set into two parts. So we have this data set, right? So we divide this entire data set, can be millions of rows. Okay, we divide them into two parts. One is the training phase and one is the testing phase. Okay, I mean, one is used for training purpose, one is used for testing purpose. In training per phase, what we are trying to do is we are trying to read the data. Okay, we are not using it to come up with a model. We just feed this data to the algorithm so that you can find similar data points. So once we feed it to the algorithm, it can tell us, okay, the new movie sounds similar to Dangal. It doesn't sound similar to the rest of the stuff. Okay, that way it helps us to get the nearest neighbors. Okay, and in the testing phase, what we do is we try to find an optimal k value, this k value. How do we do that? To do that, we need to experiment with different k values. Generally, an odd k value is selected to help with majority voting. Like we can experiment with 1, 3, 5, 7, and then we try to see how much accuracy we get from those values. So for each k value, we find accuracy using the test data. And accuracy is nothing but the number of correct labels divided by total number of labels. Okay, going back to our data set, say this was one of the similar movies. Similarly, say we have 3 movies. Now we use a value of k as 3 or 2, and then we try to validate if the test data, we pick something from the test data. Okay, our training data can be like 60% of this data set, and test data can be say 10%, 20% of this data set, I mean whatever remains. So in our test data, we try to see whether the k value that we came up with is able to give us a good accuracy or not. Okay, so accuracy is like so we come up with the k value, we know the similar movies. Now we try to see for a new movie whether, for instance, if we know that there's another movie, say the most recent one, Thugs of Hindustan, and it was a hit, but we want to see whether from the training data we can come to that conclusion or not. So when we feed it to the algorithm, we get an output say hit. Then we check, okay, was the result fine or not? If yes, then it means that we are getting a good accuracy. Okay, so there's some maths in it. If you look at accuracy, it's like the number of correct labels to total number of labels. Okay, so when we run through the test data, we are able to see how much accuracy we are getting. Now we talked about similarity earlier, right? So what is similarity? Similarity refers to the closeness between two objects. So there are various ways to compute distance between any two given points. Okay. If you see in the first training phase, we talked about similar movies. So how do you find similar movies? For that, you need to calculate the distance between any two movies. And to calculate distance, again, the vector concepts comes in handy. So we use it to To find out similarity, we use a concept of Euclidean distance. Again, I'm not going to go into the details of it, but Euclidean distance is the distance between 2 points P and Q. I mean the length of the segment connecting these. If you are familiar with the equations, the distance between 2 points, then it's simply square root of the difference in coordinates. So P1 minus Q1 square plus P2 minus Q2 square whole under root. That gives us the Euclidean distance. So you can go through the link if you want to understand it, if you want to go into the details of it. But it's simply the distance between 2 points in space. Okay, so we use the Euclidean distance concept. We calculate the distance between two vector points, say a new movie and the old movie Dangal. We try to calculate the distance. There are other ways also, like you can have Manhattan distance, you can use cosine similarity, Hamming distance. I'll try to cover these concepts in other videos, but for now it's important that you keep in mind that there are ways to compute similarity between any 2 points, and these methods helps us to do that. Okay, that's another concept that is crucial to KNN. So applying KNN, coming back to our movies data set, let's see how to apply what we learned so far. A new movie starring Amir Khan is coming, and we would like to predict if it will be a hit or not. So we use the following steps. Use the trained data set and test data set to find a K value. Like I mentioned, you can use these two sets that we came up with, the training data set and test, to find a K value. Find movies that are similar to new movie using the attributes like genre, director. We use Euclidean distance for this. And then do a majority vote. Like if K value is 3 and two similar movies have been a hit, then this will also be a hit. It's straightforward. Only thing is the essential concepts, like the concept of similarity, the concept of phases, training phase, test phase. Okay, how do you, the concept of majority vote. Okay, these are the essential things you need to know. Limitations are, the space and time complexity for KNN is pretty high. It's order of n into d, where n is the number of data points that we have, and d dimensions. Dimensions means these are my dimensions. Here we have 6 features, 6 attributes, 6 dimensions. Okay, so it's pretty high. If you consider the storage and all, it will be pretty high, right? OND. If you consider millions of records, then this will go up, right? Which is not good. So that's one of the limitations of KNN. I wanted to keep this this discussion very short. That's why I've tried to cover the essential concepts. I hope you get some idea. Go through this blog and also go through the links I have mentioned, and I think you will get clarity. And then in subsequent videos, we are going to look at some related concepts like overfitting, underfitting, cross validation. Okay, till then, bye.